See how that goes. But for instance, what is that? That is some serious clouds. But what is the instrumentation down there? They are ASOSes. Ding, ding, ding. Very good. Let me click that off. All right. What is, and I kind of drew it on the board, what if I were to draw some, I'm kind of not real familiar with this, but what if I would say the wind is going like this? Now we know the wind increases as you go up in elevation, but what if it's just crazy like that?
Isn't that the wind shear?
It is wind shear. Very good. Wind shear. Did that one. All right. Kind of getting the hang of things. Let's see. How do you... This one, just the drawings and photos. All right. How about, here is, let's pick blue. Here is my rendition of, what's this is supposed to be? The clouds are like that. It is a cyclone. Okay, and it's not very good, but what's that thing in the middle? An eye wall. Very good. Okay. Sorry, I'm the eye. I said eye wall, but I meant eye. You guys did a good hurricane eye. So maybe if you have your sheet here, don't look at your sheet. Your choices are going to be on the test. I think this is a multiple choice question. Which hurricane was the deadliest?
Galveston.
It was Galveston. Galveston was the deadliest. Which hurricane was the costliest? Katrina. Very good. Okay. Oh, let's see. Let's do this one. This is a good one. Bring in another photo. All right. So, I don't know. I know. There you go. I'm going to dim the lights a little bit. Well, obviously, you can see the lightning, right? I'm going to draw in some features. This might be a couple of cells. I didn't mean draw in some features, but let's see. How do I? Okay, I know. There we go. Let me pick red, something that'll stand out better. Okay. So what are these? They are overshooting tops. Very good. If I were going to draw in a couple of movements of air, I would go like that, and then I would go like that. What's the first arrow? What do we call that? Updraft. Very good. What do we call that? Downdraft. You got it. Let's see. Overshooting tops. Updraft, downdraft. All right. Okay, I'm going to focus on the downdraft. I don't know if this will work. This is one that I tried to do yesterday in our Google review session. Let me pick a different color. Okay. Here, you guys told me that second line over there is the downdraft. What if there is just some kind of intense straight line winds down? What do they call that?
Did we see that with the microburst?
I did. It is a microburst. This is a microburst. And actually, this is, remember, in lecture we talked about if a plane is flying, I mean, that's just invisible air. They're like, and it kind of comes up quickly, and you're like, I don't know. So that is the microburst. Very good. Okay, one more thing before we leave this slide. Not necessarily the microburst, but kind of take that microburst and kind of show it going this way. And if you are a person over there, you feel kind of that probably cold air coming. What do we call this?
Gust
front. It is the gust front. Very good. That's the gust front. Cool.
That's usually cool air.
Yeah, it would be cool air. This because what this is basically it's part of the downdraft. So it's cool air. There's something else called inflow, and that would be out. That's kind of hard to necessarily draw from here. But basically that would be air that's coming in. That would be warm, moist air that's feeding your cell. Okay, I guess I can do one more thing on here. Let me switch colors just because I can. All right. So what if I were to go ahead and draw a little bit of circulation here? I know. What sort of cell do we have? It's rotating inside. It's a big old mesocyclone kind of rotating inside. It's not a normal thunderstorm cell. It would be a supercell. Supersize me, a supercell. Yep, cool.
Supercells only have rotation?
I think so. No, probably not. But all supercells have rotation, a mesocyclone inside. But if a cell has rotation, it doesn't necessarily mean it's a supercell. Because you can have ordinary thunderstorm cells drop tornadoes. I guess one more thing. Let me pick a different color while we're on this. We kind of picked on this diagram a lot. But what if... No, I got a different picture. Let's stick with the same chapter, though. Yeah. I know. I need to clear something here. Okay, that's better. Too busy. All right. Here's one for you. Oh, nope, don't want to do that. This is the first time I've used this app. I like it, though. It's kind of fun. So this isn't a tornado. It's not a tornado. What is it?
Funnel cloud.
It is a funnel cloud. Very good. But tornadoes and funnel clouds can drop down from something, and I'm going to see if I can necessarily detect it. If this base went up here, and basically you kind of had a flat cloud like that, that's the bottom of your cumulonimbus cloud. What do we call that feature right there? Wall cloud, exactly. Very good. Funnel cloud and wall clouds.
If we have a picture of that on the test, will it be clear that it's touching or not?
Will it be what?
Clear that it's touching or not? Because
Yes.
sometimes it's hard to tell.
That's a good point. Sometimes it's hard to tell, and honestly, I Googled this funnel cloud because I wanted to show you a picture of a funnel cloud. But, air is invisible until it picks up something, or else a lot of times funnel clouds and tornadoes look milky white because basically water is condensing. So this is to say that there might be movement down here. I can't really see it animated. So, but like I said, when I Googled it, I said funnel cloud. This is what it's spitting back. So just kind of keep that in mind. Well, let's just finish up chapter 10. What else do we have for chapter 10? I know. Let's see. What am I drawing here? You're like, I have no idea. All right. Let's see. This. And this is all like that. And then this. Ooh, nasty. Maybe an anvil. And I have this. And then last but not least, this. And I have only that. What is that? From left to right.
MCC.
No. Well, it could be. It could be MCC. It could be 3 cells at different stages, and they're all working together. I like that. But what I was trying to describe is just the stages of development of a cell, a thunderstorm cell. But you're right. Very good. Let's see. What do we call this first stage? So the first stage is A, second is B, C, and D. Developing, or another name for developing, though?
Cumulus stage.
The cumulus stage. Very good. So A would be the cumulus stage. That's your updraft. And B would be what? What do we call that? Mature. Very good. And so let me go ahead and make sure. I'm going to go ahead and put some rain down there with the downdraft. So what stage is C? Dissipating. Very good. All right. So I haven't used this term yet. Now, actually, I think I introduced it in lecture with the cumulus stage, but this is where dry air moves into a cloud, and basically some of that liquid goes ahead and evaporates. So we get kind of an assortment of liquid particles inside. What do we call that?
Entrainment.
Entrainment. Very good.
What? Entrainment.
Entrainment.
Why did you say that with again?
And entrainment, E-N, it's like that third term under Chapter 10,
I mean, the
entrainment.
definition was.
Oh, the definition, see these blue, this is supposed to be air. This is just air from outside the cloud, and it's dry, and it's working its way into the edges. So entrainment only happens at the edges.
Is that the crisp? The crisp one?
Yeah, that would add to, I'm not sure if that would add to its crispness or not. Its crispness probably is more related to it kind of punching vertically, moving up. Okay, so that's probably its crispness. Actually, entrainment, I would think, kind of makes it a little bit hazy. Kind of works against crunchiness. Cool. All right, air mass thunderstorm, I can't remember what the question was there. Mesoscale convective complex, I like that basically they're a blob. If you were to look at them side on, this is kind of what this multi-cell system might look like. And kind of along just to finish up the mesoscale convective complex thing, if you were to look at it like the radar image, it would look like, it would kind of have, this is your weather system, and you'd have kind of hot spots within that. And remember that these weather systems kind of hit us in the evening times. Okay, and each one of the circles is a different thunderstorm cell. All right, let's see if you, along those lines, I don't know if you'll get this because it's, and oftentimes they're associated with, that should be blue. What kind of front is that? That should be blue. It is a cold front. The wrong color, but you got it by the triangles. Very good. And so one of the things that we know is sometimes we have this sort of weather system. What's that? It is a squall line of thunderstorms. Not very color correct. Okay. All right. So, and I didn't put it on your review sheet, but what are the two types of, I mean, it's listed there, but I didn't say what they are. What are the two types of lightning?
Heat lightning and ground to ground, or ground to cloud and cloud to cloud.
Exactly. And actually, I think I had, now that I think of it, I had a picture for that. Okay. Oh, darn it. Stop. It only does what I ask it to do is the problem. All right, one more time. I think you have to expand it only before you select it. Okay, that's the one I wanted to show you. Yeah, I heard you guys say cloud to cloud within the same cloud, or cloud to ground. Exactly. Those are the two types. So, which one's more common? It is. This is more common. And let's see, did I have it as a term there? Yeah, I didn't have it as a term, but when we talk about sheet lightning is not the same thing as heat lightning. Heat lightning is a term on your exam, but sheet lightning basically is a bunch of this. Okay, it's like, you know, lighting up the clouds or the sky. So speaking of heat lightning. Shall I draw my picture that I drew yesterday for heat lightning? It was pretty bad. But that's not the point. Okay, so heat lightning, you know, if this is my bolt of lightning, you know, clear over there from my, and you can't see the thunderstorm cell up there. The thing about heat lightning is that, what do you think the thing about heat lightning is? What makes it heat lightning? If I'm over here, what's unique about heat lightning? Yeah, I heard you guys say you can see it, but you can't hear it. Exactly. So why can't you hear it? It's too far away. Exactly. And so the other day, or what I did yesterday, was I said, if these are kind of sound waves, basically they become diluted as they travel, and so they don't make it to you. So you see it. And if you were another person, like over here, if you were this pink person, you would hear it and see it.
So then it would be heat lightning, for them it would be sheet lightning.
Well, actually, this is kind of cloud to ground, so it would be kind of that 20% of, ooh, that's going to get me. But, yeah. And kind of along those lines, to me, heat lightning, most of the heat lightning you see is going to be sheet lightning because you aren't going to necessarily have access to see the horizon. So. Good. Let's see. Enhanced Fujita scale. What does it classify? Tornadoes. Very good. How do you apply it? The damage. The damage afterwards. Yes and yes. All right. So let's say, and I think you had a homework like this, but let's just say this person sees the lightning, the pink person here, okay? He sees the lightning and then he hears the thunder 20 seconds later, okay? How far away is that lightning?
4 miles.
4 miles. Are we all good with that? Good. We're going with the 5-second rule, which is that kind of like if you drop something on the ground? Okay, yeah. And you pick it up within the 5 seconds, you can eat it. All right.
It's not true.
Oh, darn. It's not true? Go Mythbusters?
It's just
Okay. There goes my bubble. That's okay. Here I say general terms associated with lightning. It's a multiple choice question that basically says you need to recognize that these sets of terms are associated with a bolt of lightning. And I felt vindicated when we watched that little video, that YouTube video that said, you know, lightning is not entirely understood. It's just not. I mean, it's not entirely understood. Yeah. Dang it. Let's see. And I don't have a lot to add here, but I thought I would go ahead and bring you in, you know, this tornado alley where, let's see, where are we? It's all, the tornado alley is, I know you can't read that very well, it's kind of pixelated, but they're all so varied. But, you know, we're kind of in the outside tornado alley.
We could go to Oklahoma.
We could go to Oklahoma.
Oh.
Yeah. But it looks, in this, again, they're all a little bit different if you look on the internet, but look, who's getting the nastiest part of Tornado Alley here? I should change my colors, but. What's that? Is that Tennessee?
Yeah. So that whole color.
Georgia and Alabama.
Alabama. Wait, sorry, Alabama, Mississippi.
I have a question.
Yes.
On one of our homework problems, it asked us which would be worse if we were going to see a tornado, Iowa or Ohio. Tornado warning. If we knew a tornado was coming, you know, what would you do, and what would be worse if you were in Ohio or Iowa?
The question was just whether it's a low pressure system or not. Would you rather be affected in Iowa or Ohio? Which basically means that both would be affected the same way because the low pressure system does not delineate between a tornado or a hurricane or any other cyclone system.
I'd take an assortment of answers for that one, but that sounds good. That seems reasonable. Okay. And it's not on your test, but. Okay, which one, tornado watch, tornado warning, which one means that they've seen a tornado and warning? Very good. Very good. Okay, on to the next chapter. Let's see. If you were in, the generic name for hurricane, you know, we call them hurricanes, but actually they're generally speaking, I'm going to try it over here. Generally speaking, they are a tropical cyclone. So if you were experiencing a tropical cyclone, oh, dang it, is this? Oh. I have it on my list of things to do to get better at maps. But, okay, I'm pointing to Japan over here. They don't call them hurricanes. What do they call them? Typhoons. Test question. Yes. Let's see, what else do we have? Conditions required for a hurricane. Do you remember any of them? No? Well, what if, why do we care about the temperature of the water?
It needs to be warmer.
It needs to be warm, exactly. And do you remember the thing about the hurricanes don't want to be too close to the equator. Why is that? Do you remember?
The hurricane form when it basically forms the thunderstorms off the coast, and then the warm water feeds it, and then it's between the easterly and the westerlies, causing the convection to move it.
Yeah, yep. I buy all that. And then I think that what I was after is that they don't get the spin if they're too close to the equator because the Coriolis force is too weak. But that is right. I think that'll do for that one. Okay, you have a test question. Actually, it's an essay question, and you're supposed to tick 2 of your favorite things about naming hurricanes. Just throw out some cool things about naming hurricanes.
If it's really bad, they retire the name.
If it's really bad, they retire the name. Sad face. What else?
We have 2 sets of names that list that go by the letters of the alphabet.
Yep, they have 6 actually. 6 sets of names, exactly. And they're alphabetical. That's 2. 6 sets of names and they're alphabetical.
They alternate male and female.
Yeah, I like that one now too. They alternate male and female. They didn't used to.
After getting through their list of names, they use Greek letters.
I like that one too. They'll go to the Greek letters if they run out of letters of the alphabet. What about, do they use all letters of the alphabet?
No.
No, some of them, like I can't remember. It's like Q and Z, Y. No, I think there's a Yvonne sound. I think there's Y.
I thought there's 4 letters, or is there?
Yeah, there's 20. There must be 25 that aren't included because I think there's only 21 names. Q, U, X, Y. You were right. Y and Z. I thought that was Hurricane Yvonne, so you're right. Good. So just 2 of those cool things. Let's see. Stages of development of a hurricane. I think Tyler started mentioning easterly waves. What happens after easterly waves?
Depression.
Depression. Yep. And then disturbance. Very good. And then tropical storm. And then tropical cyclone. Exactly.
And they don't name it till the storm.
Right. Storm gets named. Perfect. Saffir-Simpson scale. Let's see. What to say about it? How many categories are there? 5. Yep.
Sorry, what was the question again?
Oh, the Saffir-Simpson scale, and I asked how many categories there were. 5. I don't think that's the test question, but have there been very many Cat 5 hurricanes? That's in the test question, but I just think this is interesting. And I looked it up because I'm like, really? Because that just blows my mind. But the ones that have reached landfall, there's only been 3 Cat 5s. Yeah, reach landfall. And I'm like, wait a minute, that's not right. Because there's a figure in your textbook that shows a bunch of Cat 5s, but they're in the middle of the ocean. Okay, so as they kind of get near shore, yeah. Okay, let's see. You're supposed to, on your test, give, I think, just one difference between how you categorize tornadoes and how you categorize hurricanes. Can you name any differences?
Tornadoes are categorized after.
That's one of my favorite, yeah. Tornadoes are categorized, like you said, after, and hurricanes are categorized during. Yeah, that's a big one. That's one of my favorite. Any other things?
Well, the hurricanes get measured by force, and tornadoes get measured by damage.
Yep. Yep.
And you only need to know 1.
And you only have to list 1. Yep. Yep. I think another one I heard was that there are 2 different scales. You know, if you want to, yeah. I don't know.
Yeah, that's what I said yesterday.
Yeah. Destructive forces of a hurricane. I'm not sure what necessarily to add there. If you're looking at your review sheet, it's listed storm surge, flooding, winds, and tornadoes. Okay, on to Chapter 12. How do you abbreviate the National Oceanic and Atmospheric Administration? Dang it. Yeah, NOAA. That's not what the question is, but yeah. National Weather Service. Where's our National Weather Service out of?
Quad
It is out of Quad Cities. Which one is bigger, NOAA or National Weather Service?
No.
NOAA. Very good. National Weather Service is more important to us because it's closer to us, but they work under the broad, the NOAA. And I'm thinking NOAA is part of NASA, or they work closely with NASA. How often do they send up weather balloons?
Twice a day.
2. Yep, twice a day. I just think that is so cool. And they all go up at the same time, which, you can't, they're like miles apart, but I just think that's neat to picture. It's like a wedding. Geostationary satellites. Can you tell me what's the difference between, let's see, the other one are polar, can't remember what word it is, but we have these, the polar ones, and then we have the geostationary satellites. What's the difference? What's significant about this?
Geostationary stay over a certain location while they forward.
They do. Yep, they stay over a certain location. They hover. They lurk. They, what's that word when you're following somebody on Facebook but they don't know it?
Stalking.
Stalking.
Creeping.
Yes, creeping. I got to admit, every once in a while, I am one of those. Okay. Geostationary satellites, and we call them GOES, and this is what we have, a GOES East and a GOES West. And there are actually some really cool new satellites over the ocean basins to look for hurricane activity. Okay, so satellites send us back information, right? Invisible, they take basically 3 types of scans. Which type of scan gives us information about heat?
Infrared.
Infrared, very good. All right. What's a basic component of numerical forecasting?
Computer, I believe, so.
A computer, exactly. Very good. And the program. I like that. The computer and the program. I think you'll do fine there. Analog method. How would you describe the analog method to somebody?
One by history, like what's happened in the past to forecast what's going to happen, what might happen in the future.
I love it. History. I love you used the word history. What's happened in the past, that next day, if it's like our day, then that's what's going to happen our next day. Is that what you were going to say?
Yeah, I was just going to say, is that what you said?
Yes. I didn't use the word history, but I like it. You look for a historic day that's just like today, and then whatever happened the next day is going to happen our next day. Good. Persistence forecasting, how would you describe that?
I assume that whatever happens in the morning will happen in the afternoon.
It's going to stay. It's going to linger. Yep. What we got now is what we're going to keep. And if you like it, good. If you don't, too bad. Trend forecasting and nowcasting both go together. And that, I'll just kind of say, when I think of that, I think of what we oftentimes do is we look at the weather map, and if something's happening out west, we're like, ooh, that's going to come our way. Whether that's good or bad, I don't know, but that's trend forecasting and nowcasting. Butterfly effect and chaos, what does it add to forecasting?
Errors, basically.
Errors, I like that. Yep, the butterfly effect. Chaos. Then actually I have one, at least, I guess just one more picture.
More chaos.
What's that? More chaos? What does that look like? Hopefully you can see it's kind of pixelated.
Oh, it's a hurricane.
No, not, what sort of forecasting does it look like? Yeah, ensemble forecasting, exactly. Okay, so basically what they did was come up with an assortment of different forecasts based upon their initial conditions, and then they picked the one. I know it's really hard to see, actually, but I need to work on, I wonder, with this program bringing in pictures. But anyway, ensemble forecasting. You can have more confidence in your forecast. So the last one there is, I think we talked about maybe 4 reasons, and I think you might have to give 2. So it's an essay question again on Friday's test. And why do forecasts go wrong? What do you think?
Weather's always changing.
The weather's always changing. I don't think that's one. But
there's no computer program that can completely mimic Mother Nature.
exactly, and that's kind of what Audra was saying. But that's what I was after.
Yeah,
The-
mine was
the computer program, and that's the same thing that Audra kind of said. The computer program can't mimic that mind of its own sort of thing. So honestly, if you put it has a mind of its own, I would probably take it. Because that just means that science can't anticipate that craziness. Okay, it's like what men say about women. I can't anticipate your craziness. So what's another one? So that was the programs are kind of, we can't get the programs right. What else?
Error and data.
Yep, error and data. And actually kind of related to error, I might put kind of the butterfly effect. Yep, error and data. What's another one? I think at least one more. I'll put up the map here. You know, are we good at getting good solid numbers from every place? No. And I think that's one of them. It's like there's holes in our data. Yeah, so there's 3. Can't remember what the 4th one might be. But you only need 2 or 1. I can't remember. I would just come Friday and take it. Okay? So Friday's your test, and this review might be available. Oh, wait a minute. No, I don't think it will.
Made with Doodlecast Pro.